Hello everyone, my name is Archaran Kumar Reddy. I am studying in SRIT College from the Department of ECE Electronic Communication Designing, Electronic Communication Engineering from the course Digital Circuits Design. Today my topic is Design Procedure for Sequential Circuits, Steps and Methodology. First of all, introduction to sequential circuits. Sequential circuits are the digital circuits whose output depends on both current inputs and past states. The design it they utilize memory elements to store information about previous inputs. Designing these circuits involves a systematic approach to ensure correct operation and functionality. It utilizes memory elements to store information about previous inputs. Step 1, Problem specification. Clearly define the problem and desired circuit functionality. Identify the input outputs and the type of sequential circuit. Example, flip-flop, resistor, counter. Determine the required timing and performance constraints for the circuit. State diagram and state table. Step 2, State diagram and state table. Develop a state diagram representing all possible states and transitions. Convert the state diagram into a state table listing present states, inputs, next states and outputs. Ensure the state transitions accurately reflect the desired circuit behavior. Here the process step 2, State diagram and state table. Develop a state diagram representing all possible states and transitions. To convert a state diagram into a state table listing present states, inputs, next states and outputs. Ensure the state transitions accurately reflect the desired circuit behavior. Present state. In the present state, there are two inputs A, B, input output next state 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1 and the next state 0 0 0 0 1 0 0 0 1 1 1 0 0 0 1 1 0 0 0 0 1 1 0 0. It is the state table of sequential circuit. State reduction and encoding. Simplify the state mission by eliminating redundant states if possible. Choose an appropriate encoding scheme. Binary gray code, one hot for the states. Optimize the state assignment to minimize logic complexity and cost. These are the design procedure for logged sequential circuits. Step 4, Next state and output logic design. Derive Boolean expressions for the next state. Functions based on the state table. Formulate output logic equations corresponding to each state and input combination. Use Karnaugh maps or Boolean algebra to simplify the logic expressions. To the next state and output design, logic design, we need to derive the expressions for the next state functions based on the state table and formulate output equations corresponding to each state and input combination by the use of Karnaugh maps or Boolean algebra to simplify the logic expressions. Step 5. Flip-flop selection and excitation equations. Select suitable flip-flops. Example: D flip-flop, T flip-flop, JK flip-flop. Based on design requirements, determine excitation functions for flip-flops from the simplified next state equations. Ensure the flip-flops inputs produce procedure the desired state transitions when clocked. Flip-flop selection and excitation equations. Select suitable flip-flops like D flip-flop, T flip-flop, JK flip-flop. This is on the based requirements, design requirements to determine the excitation functions for flip-flops from the simplified next state equations only, and ensure flip-flops inputs produce a design state transition when clocked. Step 6. Circuit implementation. Draw the logic circuit including all combinational logic and flip-flops. Connect the circuit as per the derived Boolean expressions and flip-flop excitation functions. Verify all connections and ensure the circuit correctly state mission implements the state mission. For the circuit implementation, draw the logic circuit including all combinational logics and flip-flops. Connect the circuit as per the derived Boolean expressions and flip-flop excitation functions. To connect the circuit as per the derived Boolean expressions and flip-flop excitation functions, verify all connections and ensure the circuit correctly implements the state mission. From the sixth circuit implementation to testing and simulation. Step 7. Testing and simulation. The circuit through simulation to verify correct state transition and outputs. Use test vectors to simulate various input sequences and observe circuit behavior. Debug any issues by analyzing state transitions and adjusting logic as needed. Step 8. Final validation and optimization. Validate the circuit against the initial specifications and performance constraints. Optimize for factors like speed, power consumption and area if necessary. Prepare detailed documentation for fabrication or future implementation. Figure state diagram for sequential circuit. These are the 8 steps for the designation of sequential circuits and methodology. Step 1. First, problem specification. Step 2. State diagram and state table. From the state diagram and state table to step 3, state reduction and encoding. State reduction and encoding to next state and output logic design. From step 4, next state and output logic designer. From the next state and output logic design, flip-flop selection and excitation equations. To select these suitable flip-flop selection and excitation equations, you use like example D flip-flop, T flip-flop, JK flip-flop based on the design requirements. Based on the design requirements. To determine excitation functions for flip-flops from the specified next state equations. After the flip-flop selection and excitation equations, we go for next step 6, circuit implementation. Draw the logic circuit including all combinational logic and flip-flops. For this one, connect the circuit as per the derived Boolean expressions and flip-flop excitation functions. To verify all connections and ensure circuit correctly implement the state machine. Testing and simulation. Test the circuit through the simulation to verify correct state transitions and outputs. Use test vectors to simulate various input sequences and observe circuit behavior, or debug any issues by analyzing state transitions and adjusting logic as needed. After the testing and simulation, step 8. This is the final validation and optimization. To validate the circuit against the initial specifications and perform constraints, optimize for factors like speed, power consumption, and area if necessary. To prepare detailed documentation for fabrication or further implementation, we need to check the logic circuit for final validation and optimization. State diagram for a sequential circuit. Finally, the design procedure for the clocked sequential circuits. Conclusion and summary. The design of the sequential circuits follows a structured methodology from problem definition to implementation. Each step involves careful analysis, simplification, and verification to ensure correct operation. Mastering this procedure enables efficient and reliable design of complex digital systems. This is the design of the sequential circuits of a structured methodology from problem to definition implementation, and 8 steps including to follow the structured design of the sequential circuits. To follow these 8 steps, in each step involves careful analysis, simplification, and verification to ensure correct option. to ensure correct option. Thank you. Thanks for giving this opportunity to share this information with you, and it is helpful for you. Thank you.